All right. Looks like almost everybody's found their seats again. I just want to take a minute and we'll announce the results of our election. Again, I want to emphasize that as a volunteer organization, we are dependent upon people being willing to stand up and take part, and we appreciate that. It's difficult to be a candidate. It requires an uncommon amount of courage to put your name up there and see how it goes. But we appreciate everyone who's willing to do that. That being said, the results of our election this year, Seth Homer has won the seat to be the new board member. Jonathan, thank you. Congratulations, Seth. Yeah, I'll point out that this is not the first time that Seth has been a candidate. So we appreciate him coming back. Jonathan, thank you for being a candidate, and don't let this be the last time, okay? Well, welcome back Dr. Tracy Farone to discuss with us Varroa control this afternoon. Just as an item of housekeeping, as you leave the conference today, there's a whole table full of catalogs and things out there. Please take as many as you can or want. Make sure there's one in each bathroom of your home. If you are part of an organization that would like to have them, please take them. We don't want to take any home. Well, Glade doesn't want to take any home. I'm not taking home any anyway. But thank you for being here, and we'll welcome Dr. Farone.
All right, thanks guys. It looks like somebody, someone read my chat. I was hoping to see a picture of you all. I can put my video on maybe for a little bit, not kill the whole thing. Yeah, okay, great. Yeah, because it's so different talking online, of course, and talking in person. So how many, if I can get a poll, how many of you guys are small, operation or backyard beekeeper? Give me a sense of, okay, so a good chunk of you miners. That'll admit it. Well, maybe one. I don't know if I can see the whole. How about my commercial beekeepers?
Commercial beekeepers?
What's that? Commercial beekeepers. How many commercial beekeepers we got? So I see a couple hands. Yeah, I see a couple hands. All right. So am I correct in what I can see from the crowd there that the majority are backyards, small scale kind of beekeepers, and then we got a few commercial mixed in. Is that right? Is that a good assessment?
That's right. Probably okay. 80-20.
Okay, perfect. Yeah, I kind of like to know who I'm talking to, so I can make maybe a little bit more sense. Yeah, so have you guys thought of any more questions from the last talk?
What do you know
that
about
came up? What's that?
Stages.
Stages?
So a treatment for an active American foul brood case was developed, I think.
What?
I think it's called phages. It was a treatment that was.
Okay, phages, like bacteriophages.
Oh, phages.
Yeah. I thought I was hearing phases, like we were going through, phases of life or something. Yeah, yeah, bacteriophages. Yeah, I don't know how that is. Does anybody use that and had any success?
There was a local company that resulted from some research done at BYU that for a few years was producing them, and it was quite a promising treatment for rehabilitating an infected hive, but they ran into an FDA buzzsaw and kind of petered out from what we understand.
Yeah, I honestly don't know much about that. I mean, I've heard of it before, but I don't know how effective it's been. I thought you guys were going to ask me about shaking like hives out. Some people will try that. Usually that's more successful with maybe European foul brood, but honestly, if you've got a clinical case of American foul brood, you're really behind the 8 ball on that one. No one wants to burn a hive, but that's kind of where you're at. Was there any other questions about vaccines?
Doesn't seem so.
Okay. Yeah. Well, I don't work for Dalen, so you can ask me any questions and I'll tell you exactly what I think. So I just want to make that clear. So I try to educate people about the science. I just work at a small Christian school in Pennsylvania. So I'm all about education, and that's pretty much where my shtick comes from. So anyway, so let's talk about Varroa. Varroa Destructor. Anything with the name Destructor as their species can't necessarily be good. And I have the world here because have you guys heard about what's going on in Australia with Varroa?
Yes, no, not recently.
Yeah, no, yeah. Well, I'll give you a little update on that then too. But yeah, it's pretty much worldwide. I don't know that there's any in Antarctica, but I don't know if there's any bees down there either, so. Anyway, so here's some, we'll start out, if I can get the slides going, there we go. So believe it or not, this is me, the person wearing two kinds of gloves here because I couldn't find anything else, out in Montana. So I have been out sort of in your neck of the woods. I realize things are pretty wide and spread out west. But I had the wonderful opportunity to hang out with some beekeepers, some commercial beekeepers, and see how they do some things. And you can see, this picture didn't come out real good. I wish it was a little bit held the whole, because the guy that was helping me here, his head was like up here a little bit. Here's me, right? So, but they let me hang around and learned a lot from you guys. I enjoyed hanging out with beekeepers, and so much that I became one. So I'm empathetic to both sides of things, and I can talk to veterinarians and I can talk to beekeepers, and I so much appreciate you guys letting me talk to you today. And so sorry I couldn't be out there to meet with you in person and have lunch with you and have those little side discussions that mean a lot, but I'll do what I can here. So realize this is my bias. I am a veterinarian and I'm trained as a clinical doctor, and this is my approach and how I think about things. And it's something that I think bees being one of the most, if not the single most, it's certainly one of the top 3 most important agricultural animals that we have in producing food for us. So they haven't had a doctor to look at them. And I think if anything else, it's more than just antibiotics and VFDs and prescriptions and things like that. It's someone coming alongside, and it doesn't have to be all of us, but some of us, just to give some perspective on how to work through diseases. And, no matter what kind of patient we're looking at, we have to think about, what's a good history on a patient. And history doesn't mean like, okay, did George Washington chop down the cherry tree? It's a history of your patient that could be significant to what's clinically going on. How many hives are there? What historically has been done with management? What are recent events that have occurred that could have affected the disease implications there? So those are questions, that we start out asking, and we may ask beekeepers a lot of questions, or I ask any clientele, if you bring me your dog, I'll ask you a lot of questions first before I really do anything. And that's a good history, and we'll work through this. And then doing a good exam, beekeepers call those hive inspections. When you're opening up a hive, you are doing an exam on that animal and on that superorganism. And then looking for clinical signs, just like we were talking about American foulbrood. When we look at larvae that are turning into a ropey mass, or the black scale, the smell that smells like necrosis. When I teach veterinarians about what American foulbrood is, I tell them it smells like necrosis. Now that's not a term you can use in most audiences, but I bet you guys can figure it out. Necrosis is it smells like dead tissue. And that's what hives smell like with American foulbrood, if you guys have smelled that before. Dead, and not dead like a dead animal, dead tissue within something that's still alive. That's a different smell. And once you've smelled that, you never forget. Differential diagnosis. That means that unfortunately, there's no rule out there that says you can only have one problem at once. You can oftentimes have more than one thing going on. And when we look at different clinical signs, some can look the same in different situations. We have to write a list of, okay, what possibly could be going on. And sometimes more than one thing. Being able to do diagnostic tests, and this just proves you can't necessarily just look at clinical signs and prove that that's what's going on. You can certainly expect things from clinical signs and history, but you've got to do screening tests, screening tests like for American foul brood or your whole milk test. We also have some ELISA tests you can do right in the field there, but ultimately you got to send it out to a lab where they do culture and confirm that that's what you got. But it's certainly nice things that you can pretty much diagnose there in the field, so you can take action as soon as you can. And then we develop treatment plans. And I was thinking about the last question from the last presentation. I hope I answered the gentleman's question as well as I could. But just like with the vaccine, I mean, that's just one part of any given treatment plan. Assuming that it works, you have to implement multiple things oftentimes to fully cover.
Close to.
There, so I think you lost me again. Am I back?
Yes.
Okay, sorry about that. So I think you probably heard up to treatment plan. Is that right?
Yes, multiple treatment
Yeah.
plans.
So usually there's multiple things involved in any kind of treatment plan we develop. And then it's always nice, the old adage is, an ounce of prevention is worth a pound of treatment or something along that line. It is nice to be able to prevent things if we can, if possible, or learn about things so that we can prevent them in the future and do things to avoid it. And sometimes that's not medication, sometimes that's actions. When we talk about disease in any type of public health implication or any type of framework, we always have to consider what's going on with the agent. Now that's the pathogen, okay? Whatever's causing the disease, the host, which in our case is going to be bees, or this could be any animal or a person, and then the environment. All three of these things are related in how they interact. And we can do things at each one of these points, perhaps to help control or prevent or treat disease. We have to be thinking about all of those things at the same time to try to best handle whatever we're dealing with. Okay. I'm trying to fast forward. There we go. Okay. So there's Varroa mites. I'm sure most of you have heard of Varroa. If you're a new beekeeper, someone probably needs to come beside you and kind of pat you on the back and hold your hand and tell you that things will be okay if you've never heard about Varroa, because this can be a little scary if you're a new beekeeper. But it is considered by far to be the most destructive pest of Aphis mellifera, which is the western honeybee, which is what we have here in the U.S. Again, some of the older texts, and there is another species, Jacobsoni, that isn't really the one that we deal with. We actually deal with Varroa Destructor, and it actually causes the disease. The proper name for the disease is varrosis, 2 O's in that disease name. And it's one of those things where if you have a beehive, you have a colony, it's really not a question of whether you have Varroa. The question is how much. And that's something that sometimes beekeepers have to come to terms with. And it's a lot like, I was clinical practice, and the psychology of it was a lot like fleas. I would have people bring their dog or their cat to me, and they'd say, my dog or cat doesn't have fleas. And they thought it was sort of like a judgment or something. Like they were a bad dog owner, cat owner. And I could scrape the flea dirt right off of the dog or the cat and show it to them. And I'd still be like, no, I don't have fleas. Yeah, you do. And then we'd have to have a long talk. Well, the thing is that everybody's got Varroa. So we're in this mess together. If you got bees, you are also the proud owner of some Varroa mites. So we got to get past that, right? And have that little talk. Pathology, though, is a bit like ticks. You guys got ticks out there in Utah? Or they don't like? Yes. What kind do you got? Deer tick? What you come here all? I'm hearing all kinds of answers. You got Lone Star ticks. They come up from Texas. And people call them deer ticks. They're usually some kind of Ixodes tick all over. They're everywhere. But if you know a bit about ticks, is that they will attach to their host and they will take a blood meal. When they do that, they often vector other diseases, and that's somewhat similar to what Varroa does to bees, except as we talk about it, they don't just suck their hemolymph, they actually suck out their fat bodies, which would kind of be the equivalent of ticks, not just sucking out your blood, but sucking out your fat and your liver from your body. If you give you a nice mental picture, and then imagine that the relative size of those ticks on your body would be about the size of your fist or a softball. So that's how big these are compared to our honeybees. So really, really nasty ticks. Perspective. All right, you guys just had lunch too, right? So I just messed that up.
We're here.
All right, okay, so I'm going to walk you through. Sorry, veterinarian, here we go. A little bit of history. These are my bees, aren't they pretty? So when it comes to learning about what your bees could be susceptible to, whether we're talking about Varroa or anything else, and I talked to a lot of beekeepers about this. The things that I have up here on the top, boom, boom, boom. If you are a new beekeeper, you're a backyard beekeeper, read everything you can about the normal biology of bees. You have to. And I teach anatomy and physiology to my students, and they all want to become doctors and like solve everything tomorrow. And that's a really nice thing to, really nice ambition to have whenever you're 20 years old. But I tell them, you know what? You can't know how to solve what's abnormal before you know what normal is. So you have to learn everything normal about anatomy before you can learn how to fix pathology, right? So I would tell you guys to learn as much as you can, become bee biology experts, because if you understand normal biology, and whenever you open up a hive, you'll be able to look in there and know what you're actually looking at. And that takes some time to do. So spend some time doing that. Spend some different resources, talk to different people about it. As a beekeeper, that's one of the basics that you need to cover to keep your bees healthy. Second thing is good nutrition. Your bees have to have good forage. What's the forage like out in Utah, where you guys are? Is it mostly desert, or do you have like a mix of
Agriculture?
Okay, so you move your bees. So you have what's your main crop out there?
Alfalfa.
Alfalfa. Okay, well, all right. A few other things. Okay. So, and nutrition needs to be diverse too. So it's, where there's a lot of talk about pollinator-friendly plants and things of that nature. Do you guys use supplements much out there for your bees? Supplementing sugar water as well as syrup and or pollen?
Yes.
Yeah. So, obviously the best nutrition for bees is natural forage, and a diverse natural forage, and you may have that depending on where you're at. But certainly as beekeepers, we can manage that somewhat to make sure that they're getting good nutrition and nutrition that they need at a seasonally appropriate time. So you need to study up on that. The third thing we can do as beekeepers is to reduce diseases. Now, notice I don't say eliminate diseases. They're eliminating diseases very few diseases that we have eradicated from the face of this earth. Only 2 of them, actually. Anybody know what they are? Anybody know what diseases we've actually eradicated from the face of the earth? Only 2. Smallpox is one of them. Good. See, if I had a little star, I'd give you one right there. Smallpox is, people usually know that one. Do you know what the other one is? Any cattle people there?
What?
Yeah. What's that?
What did you say?
Yeah, it's actually a disease called rinderpest. Yeah, it's a tough one, I know. It's a cattle disease called rinderpest. It was known as cattle plague. They eliminated that one through vaccination. But yeah, and the whole history of all our science, everything else, we've only ever eliminated 2 diseases, and only one's human and the other one's for cattle. Anyhow, so we've got to reduce disease. We can control it, control our parasites, primarily Varroa, and control other pests and try to reduce our environmental stress on our bees. The other 3 on the bottom here, where I have good genetics, you know, I have that in quotes. I think we could probably talk about that, and everybody could have your own conference on that, and you know, what good genetics means in bees. Certainly, I'm not going to get into any arguments with queen breeders, but you know, requeening sometimes does fix a lot of things for whatever reason. But that's one I like to kind of just skip over and kind of keep in that lower column. Good beekeeping and husbandry, we certainly don't want to do anything that would be breaking these rules up at the top, and not understanding normal biology, not giving them good nutrition, not reducing their diseases. And then there's everything else is really subject to a lot of opinions and preferences. Now, I've been in a lot of beekeeping meetings. You can talk about whatever you want. You know, what's the best bottom board? What's the best you know, cover at the top? What do you do in the winter? All these different things. You know, and a lot of them might work depending on what your situation is and your goals. But if you don't do these top 3, which often results in the bottom taking care of everything else at the bottom, you're going to have issues. The other thing you need to understand for Varroa, and really anything else, is how diseases get transmitted. One is trophallaxis. Trophallaxis is a fancy word for bees that share food, and they share everything within a hive. Every bee in that hive shares everything with her sister and maybe her brother. So if bee comes in and brings in 1 drop of nectar, it gets spread out throughout that whole hive. So it doesn't take long for, if one bee gets exposed to something, everybody else in that hive is getting exposed too. There's about a 3-mile flying radius. I mean, some sources will go up to 5. I think that's a little far, but probably 3 is a little more realistic. So everybody within a 3-mile radius could potentially, your foragers could be bringing that back, or your drones could be bringing that back to the hive. We also know that bees drift a lot. They drift from hive to hive. One fun experiment my students did, and you can do this too, and you take some of your queen marking pens that are off for that year, and you start marking a bunch of drones in different hives within your yard. Pretty soon all the drones, it'll look like a rainbow inside your different hives, because they drift like crazy. Robbing, we know that bees rob out other hives, especially. Do you guys have one main nectar flow out in Utah? You have, yeah, you have one. Yeah, yeah, it's a little bit, I know out west. Yeah, yep. So you have like a summertime flow, you know. Yeah, in Pennsylvania here, we actually have 2. We have a spring flow and we have a fall flow. Our fall is usually a little less, but we have what's called a summer dearth. I remember when I was talking to the beekeepers in Montana and I was asking them about a summer dearth, they looked at me like I was crazy, because you guys don't have one out there. But we have kind of this lull in between our spring and summer, our spring and fall, and we get a fair amount of robbing during that time. Do you guys get robbing with your bees?
Yes.
At a certain time?
No.
Yes, no. Depending who you ask. All right. And then close contact. I mean, you've got 10,000 to 80,000 bees in one hive. Doesn't take long to spread things. Fomites. Here's a word that you guys might not know. Fomites means an object that can carry disease, like your hive tool, for example, or anything else that you have laying around the yard that could pick up any type of pathogen. You could move that from one hive to another or one yard to another. You can actually spread disease that way. Feral colonies. Feral colonies are, ones that have swarmed, gotten away, living out in nature. They can harbor diseases, and as beekeepers, we're not treating them, so they can intermingle with our bees and spread disease and act as a reservoir. And then beekeepers in general, I mean, we're much like our bees in that we share a lot of things. A lot of beekeepers are nice people and share things. Share old equipment and trade things and of that type of nature, but sometimes that breaks down laws of biosecurity and can bring things into your yard that you shouldn't. All right, so here's a picture I took. Here's a bee tree. Do you guys have bee trees out there where feral colonies hang out? Most of our feral colonies don't make it through the winter here. They're usually dead out pretty quick. And the reason is usually Varroa. So here's a Varroa mite. This is not my picture here. This is an Alex Wild picture. But here's a mama mite. And in the background, what you have here is actually a pupae. So I have a fairly simplified life cycle here for you of how Varroa, how their life cycle essentially infects a hive. So you get a mother mite that gets brought into the hive through many of those different modes of transmission that I just talked to you about. And she gets into a larval cell. So it's an open cell. And she goes in there, and while it's being fed by the nurse bees, she can feed off that larval food. And then once it gets capped and the pupa is capped over late stage larva into the pupa, she'll actually start to feed off of the pupa as well. And that can, of course, you have pupa that are weakened in their developmental stage. Then what the mother does is she lays eggs, and she usually lays females, maybe 1 or 2 eggs, depending on the situation, and then also a male. And the males mates with the females, and yes, that's their brother and sister. And the females typically emerge whenever the bee emerges, whenever the pupa emerges, and then that spreads out through the hive. So you get at least 2 pregnant females spreading out through the hive. The male usually dies at that point. And they prefer the drone brood. And the reason they prefer the drone brood is that gives them a little more time to lay eggs in the drone brood. The mother might actually lay a 3rd female. So you'll definitely get 2 and maybe even 3. So your drone brood, the mites are actually like to be in there because there's a little bit longer development time for a drone. And that can be a management strategy that beekeepers use. You may have heard of that, of removing drone brood or removing some drone brood, because that's where a fair amount of your mites may actually be. And if you remove that drone brood, you can break down potentially some of your mite count. Most studies on this, if you look at it, they say it doesn't hurt, but how much it helps is probably minimal. Certainly, it's something that's labor intense. You'd really have to be doing it a lot. And then there's some schools of thought that are on the side of the drone that having some drones around is a good thing too. But drones can also be a little bit of a drag on the hive too, because they use resources and things. So I think with drone brood, if you want to knock some off here and there, it's probably a fine thing to do. But I wouldn't spend all day long inside my hive knocking out drone brood. It probably just isn't worth it. And we do want some drones around. So many mites, remember, are going to be in the broods. What's important about this life cycle is they're going to be inside the cappings. All right. Some of them are going to come out into the adults in between, whenever they're kind of spreading out in the hive. And in the last presenters, you heard them call that the phrenic stage, right? But this is something that the treatment challenge is there, right? So we have to have a treatment that's going to get it on the adults and also in the brood underneath those cappings. And treatments we have, some of them work for the brood and some of them work for adults. So it's important to choose them at the right time. So here's some lovely pictures of Varroa if you want something for your wallet. We've got they're big fat mites, really. And they actually have 8 legs if you can look at the bottom of them. This is actually a scanning electron micrograph picture that we took in our lab with one of our mites. If you really want to see her up close. So if I was talking with a beekeeper and they were having issues with Varroa, I would, kind of start out with some of these questions. And the first question, if someone has lost a hive from Varroa, is, have you been treating? That's a yes or no question. And then, the question after that is, well, what have you been treating with and how have you been treating? And we'll kind of get to that. But if you haven't been treating, typically what's going to happen with your hives is they're going to be progressively taken over by these mites. And it may be slow at first, and you can have a hive that looks great in the summertime and lots of big population and all that, and then collapse fairly quickly, sometimes even in the fall or certainly over the winter. And some of them may just kind of slowly collapse or just be kind of poorly doing over a year or two. So as this progresses from the Varroa stage, and then as some viruses come in a couple of years, you have dead hives. This is also kind of corresponds with the average lifespan. I don't know if this is true in Utah, but I think it's true in most places, is that new beekeepers that maybe don't quite understand what they're getting into will lose hives early on, and new beekeepers may not last without help and support, having a mentor more than 3 years, because they get tired of their bees dying all the time. And this is one of the big reasons why. So like I said before, parasites feed off of the bees' fat bodies. We used to think it was their hemolymph, but with new research, it's primarily they're sucking out their fat bodies, which is fat and appropriate reserve for energy. But their fat bodies also act a lot like their liver and their immune system. So it really destroys a lot of their ability to maintain good metabolism and good immunity. So that leads to a lot of things: low protein levels, deformities that you can actually start to see in the bees. They will become smaller, weight loss. They may act strange. You can see neurologic and behavior changes. They're not able to perform their tasks well. And really things within the hive start to fall apart from a managerial standpoint. And again, reduced immunity. So after we get through all of that historical information, then we got to look and see what we got with that exam. And along with that exam, whenever you're looking, you can do a diagnosis. Now, hopefully some of you guys have seen this. I've got foul brood test down here. That's for another time, but hopefully you can recognize that this is a container that we use. It's a commercial container, and you can make your own, but this is a commercial container for an alcohol wash. Looking at bees, and you half a cup bees here, take a scoop of bees, live bees. Half a cup is about 300. Somebody counted that out at some point. Pour in your isopropyl alcohol, or have it already in there, I recommend, and dunk the bees in. It does kill them almost instantaneously. And you shake that, and through these little holes, the mites can come through, and then you can look at the base here and see what you got. And there's different methods out there for mite levels and monitoring mite levels and checking mite levels. You don't know what you got unless you look. And there's different ways of doing that. One is an uncapping fork, another is a sticky board. Now you notice I have question marks here. Because if you remember what I said at the beginning, it's really not a question of, do I have mites? It's a question of how many do I have, okay? And uncapping forks, this is they're running the fork through the drone brood down here, and you can actually see the mites. They'll be like little dots of brown or reddish brown. And then you go, oh, look, I got mites. Well, yeah, I could have told you that. It won't just getting out of my truck that you got mites because you have bees. The same thing with a sticky board. You can say, oh, well, there's some mites down here stuck to the sticky board. Yeah, there's gonna be because you got a honey bee hive. So, these are not real good at quantitatively testing what's going on in your hive. What you really need is to get a quantitative test. So these are qualitative tests, right? They're like a yes or no. And you really want which is going to be like your alcohol wash, which I just showed you, which is really the preferred method, and that's the camp I'm in, and it's probably the biggest camp. But there's also powdered sugar roll, which is here in these pictures, where you put the bees in and you put powdered sugar on them and you shake them and you look for mites too. The big controversy between alcohol wash and powdered sugar roll amongst beekeepers is with the alcohol wash, you kill 300 bees. And the alcohol wash is going to kill all the bees. Powdered sugar roll is probably not going to kill most of the bees. It still does kill some of them because powdered sugar can be an irritant to their gut. You do take them in there and shake them around, and then you throw them back in the hive, and everybody feels good because you can throw them back in the hive and think they're all alive. We've actually done some studies on this with students, and some of them do die, or they die after a while after being through the trauma. But I understand that nobody wants to kill bees. I don't like to kill bees either. But whenever you're taking a sample of bees, 300 bees out of a hive that has 10,000 to 80,000 bees, that 300 bees is much like taking a blood sample and out of a organism and testing it for a disease so you can save the rest of the hive. So you're really not making a huge impact on the organism by killing 300 bees. And with powdered sugar, you're probably killing more than you think you are, at least initially anyway. But the important part is alcohol wash, powdered sugar roll, you at least can count and get a quantity. Most studies are going to tell you that an alcohol wash is going to give you a more accurate count, which is another reason why I like this, because if you get a powdered sugar roll and it tells you less than what you actually got, you may delay treatment, and that might be a fatal mistake. So with an alcohol wash, again, what you do is you shake 300 bees, which is about a half cup of bees, and you really try to get nurse bees, okay? So you get the frame that has the brood, right? And you really, 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 really check it out because you don't want the queen on there. Okay, that's the number one rule of the alcohol wash, or by the way, a powdered sugar wash, is you don't want to shake the queen or wash the queen in any kind of way, because then you won't have a queen anymore. And you put them in. I like to take that frame, and I guess there's different methods in that frame that I've selected. And comes that video. Take that frame that I've selected, and I shake it out to a nuke box, and then I take my scoop and scoop from the bees that are left there to try to get my nurse bees. You add the alcohol, or you already have the alcohol in there. You dunk the bees in; they pretty much die straight away. And you shake it for about a minute, and you can, if you have the powdered sugar, you can actually sift that onto a white background, and you can look either at the alcohol wash or look at what you've sifted out from your powdered sugar, and you can count the mites. All right. I really think commercial kits are worth it. I mean, you can make your homemade kits, that's fine, but commercial kits are they're pretty standard, so they're going to give you maybe a more accurate count. Now, one question that I always get from beekeepers is, how often should I test? Some of the universities out there will tell you should, I've literally heard this, you should test every month. Well, I think they mean every month during the beekeeping season, because nobody's tested in the middle of winter. So that's going to really depend on where you're at, right? and what your season looks like. I think from a practical point, it's probably, if you can get it done 3 times a year, that's going to be good, right? So you get a spring count. You first get into those hives, so you know what you're dealing with straight away in the spring whenever you're able to start doing some inspections. You take one in the summer, and then you take one in the fall. That way you know what you're getting into as you go into winter. I think that's practical, and it's going to give you the best information on your management. If you do it more often than that, great. But I don't know if it's going to change much about what you would do, right? Now, certainly if you want to be all scientific, you can, when you administer a treatment, you can take a mite count before and after that treatment. That's not a bad idea, if you're out there trying to take data, but if you're trying to manage a yard with a few hives in it, it may not be practical for you to do that every time. But if you have a treatment that maybe is going ineffective, or you feel like you're developing some resistance to, not a bad idea to evaluate it before and after. There are internet videos abound on how to do sugar rolls and how to do that. If I was there, I'd show you, but not today. So what's a bad level? Well, it depends largely on the time of the year, and this is because of the life cycle of the mite. 3 mites in the spring is a much bigger deal than in the fall, because they typically will multiply exponentially as you go through the year. So you start out the year with 3, that's going to be a much bigger deal than if it's in the fall. But essentially, when you're shaking your bees, the standard that they've come up with is 3 mites per 100 bees, okay, or 3% is your treatment threshold. So if you say, okay, well, I shook 300 bees, now you got to multiply that by 3, right? So up to 9 mites in your counts, okay? You get 9 mites in your count, you better be treating like now. Once you get into 5 mites per 100 bees, or 15, right, for a 300 bee count, that hive is sick. It's clinically ill. Considered clinically ill with Varroa infection. And if you have 30 or more in a 300 bee count, that hive is in danger of not making it through the winter. So you better do something pretty quick, and that hive's probably still going to be in danger. Have you guys heard of the Honeybee Health Coalition?
Yes.
Yeah, good for you. So they have, if you want to know how to manage Varroa, you can get on their website. They have a Varroa tool there. They have all different types of recommendations. So, here's the link, and if you're familiar with them, certainly they can tell you everything you ever needed to know about starting a Varroa management program within your hives. I wish I could tell you put one medication on your hive, starting in the spring, and they're good for the rest of the year. Unfortunately, that's not how it works. You usually have to have multiple treatments going on at different times of the year, depending on what's going on with your bees. So most beekeepers that are successful are doing at least 2 different types of treatment during the year, and I think a lot of them are up to 3 at this point. I'll tell you what I do, but everybody has their own method. I just want you to be doing something. So, the good thing, I guess, about Varroa hive treatments, this is the worst disease bees get, and certainly you don't need any veterinarian for any type of medication prescription here. But you do have to understand how these medications and these chemicals work. They vary in application type, their effectiveness at certain times of the year, their effectiveness with different temperatures, how long you have to keep them in the hive, the timing of the treatment relative to the year and the season, whether you can have that treatment on whenever you have honey supers on or not, whether it's safe, and whether that treatment works with brood or no brood, gets under the cappings, meaning, or if it just kills the Varroa on the adults. So again, reading the instructions, that's an easy thing to say, but nobody ever does it, right? But it is very important. If you want to make sure your treatments work, you can't just throw something in a hive and if it doesn't work, be like, it just didn't work. Well, make sure you go back over those instructions and you're following those appropriately. And develop a plan. Develop a plan for your beekeeping season. You really need to have something going forward so you can be proactive instead of reactive. And keep records. I don't know if this happens in Utah, but this happens in Pennsylvania. You can tell me. The beekeepers keep records of hives by bricks on the top of the hive. Like if the bricks point in a certain way, does that mean something? I can't hear you guys. Heard some rumblings. Some people do. Okay, yeah. So you got a brick, pointing to the north. That means something, and brick pointing to the south. That means something else. Yeah, and so that happens out in Pennsylvania too. And I used to laugh with some of the guys I'd go out with, and they'd have their bricks all moved around, and they'd go, "Wait, I think I forget which way that goes, right? What happened?" But if you keep records, you'd be surprised what you might find out. If you can keep records, that is so helpful in any type of management. And it doesn't have to be elaborate, but keeping records of what's going on with your hives, or even some sort of identification on your hives, whether it's even putting cow tags, ear tags on your hives to know who you're dealing with at any given time. All right, so here's some common treatments. You guys had just had a lecture about a new treatment that's coming out. I jumped in at the end of that to get to hear all of it. So, it's always exciting if we can find new treatments that may be effective against Varroa. Now, I have some of the ones listed here. I don't necessarily endorse any single one. I've used several of them myself and seen others use them. Hop guard, and I have just kind of a shorthand of what they can do here. It comes in strips that you put in a hive. One benefit is you can use them whenever you have honey supers, but they are temperature sensitive. Do you guys run into temperature sensitive issues when you're out in Utah? You guys get pretty hot out there?
Yes.
Yeah, I would imagine, being out there in the desert. So some of these things, that might just not work for you. And I can tell you, I've used Formic before, and I looked at the long, which is also temperature sensitive. I looked at the long range forecast, and it was going to be perfect. As soon as I put those Formic in the hive, it was 90 like the next day. So it never fails. That good planning sometimes doesn't always work. But anyhow, it is temperature sensitive. So you start getting up above 90 degrees, it's going to be an issue, and it needs to be above 50. So you have a window there, and it doesn't do anything for the brood. And then they have the duration of treatment there too, which can sometimes be a factor. Formic comes in a couple different forms. Mite Away, Formic Pro strips. Again, you can use this with the honey, and it is labeled to kill under the caps, but it is temperature sensitive, and if it gets too hot, this will vaporize out pretty quick. And I've seen queens. I'm sure you guys have too. This kills some queens. You can do it in a couple different treatment types or times, depending on how many strips you put in. So it can be relatively quick or take a couple weeks. OA, oxalic acid treatment. You can use either a dribble or a vaporizer. A lot of people like this. I'm actually kind of a fan. I use OA and a vape treatment in the fall. It's kind of a cleanup treatment in fall. Doesn't work under the brood, so you do have to use it at times whenever you have low or no brood. And I use it several times. Where I'm at, I use it in the fall, usually November, a couple times. You can't use it with honey though, or it's not technically should be used with honey. That's been a little bit of a controversy with EPA lately, but they're not going to enforce it, but you're not really supposed to. Apivar or Amitraz, Apivarus strips. Again, you can't use it when you got honey on. The treatment is pretty long. I have used Apivar, and I use it in my neck of the woods in between after I take the supers off in the spring. I put it in all summer, essentially, until I'm ready to put the supers on in the fall again. So that works for our system here, but it may not work for everybody. We are starting to see some resistance with Apivarium Traz being reported. And then Apigard, I think the last talk, did talk a little bit, or they used the comparison of thymol. I can't use that with honey, and it is temperature sensitive like some of these, and it does have maybe a longer duration of treatment. And then there's all kinds of homemade treatments and essential oils and treatment-free, and different opinions on how to treat or not treat. That's what's out there. I certainly would be on the camp of treating, and probably, I'm going to go back for a minute, where I'm at right now, what I'm using is some combination of either hot guard or formic, and then Apivar and OA. So you have treatments available that you can use with honey if the counts get high. This is my summer treatment in between my 2 honey flows, and then I use OA in the fall. So there's reasons for treatment failure. Certainly expired drugs. Expired drugs do not work as well. And they may not cause toxicity, but they just don't have effectiveness. And that might be one reason, and this happens, you take a strip of whatever, formic or Apivar, and you leave it in your truck, or you leave it in your bee shed or whatever, and they're expensive and you don't want to buy other ones, and you just throw them in and say, and upon work. It might not. So be careful with that. Incorrect dosage. You don't use it correctly. You put too much in, or you put too little in, or you don't leave it in long enough. Incorrect timing. You use something that doesn't get under the brood whenever you have a bunch of brood at that particular time in the season. Leaving it in long enough, leaving the treatment in long enough, doing it as more times as it recommends. Incorrect application, not putting it in properly into the hive, or not taking it out, maybe. Actually, leaving it in too long can be an issue. One funny story I like to tell, and this isn't necessarily a bee story, but it gets the idea of incorrect application. One complaint I used to get for flea control with dogs and cats, and a lot of flea controls, if you guys have any dogs and cats, I'm sure there's some of them in there. And we get a flea treatment that would be a topical treatment. We would put on their skin, between their ears or something on their head. And that was the proper way to apply it. And we would get complaints that the animal still had fleas and was having trouble. And we would ask what they did, and say, well, they don't, we still have fleas, and they just keep foaming at the mouth like crazy, and what they were doing was they were giving this topical flea treatment orally, or trying to give it orally to a dog or cat. And obviously that's not going to help. It's going to cause a problem. So make sure you're doing things. Funny things happen. Make sure you're doing things. You got to read the directions. Lack of record keeping. You forget. You think at the time that you're going to remember. And I'm getting to the age where I've had to come to terms with that myself. And I realize that I can't remember everything, and I better write it down. And you can be like, well, what did I do to that hive, or when was that? So keeping some records can really help you know what worked and maybe what didn't work. Maybe you should treat differently at another next season. Are you seeing some resistance, or something isn't working in your hive? Keeping a record of that is one of the best ways to recognize that, and recognize it as early as possible. And this is the picture in the background. I think you guys probably recognize as a stinger, bee stinger that we took. This is from our lab, one of the electron micrographs, so the scanning electron micrograph. So what a scary stinger picture here. So certainly there's always newer treatments coming out. I guess you guys just heard about one, and I missed part of that talk, so I only heard some of the at the end there, but I came in. Thermal treatments. I don't know if anybody's selling thermal treatments out. You guys heard of thermal treatments for Varroa?
Heard of it.
Yeah. Yeah, it's kind of a newer, I don't know, trend, craze, whatever, where they're heating the hives up to 107 degrees with this apparatus that they put on the hive for a couple hours. I have to admit, I'm kind of apprehensive here, because putting a heat source on a thing that's made out of wood with beeswax for a couple hours doesn't sound like a smart thing for me to do, just from a fire safety thing. But you know, bees are resistant to heat. They can handle a lot of heat, and apparently heat will kill off the Varroa. Whether this is practical, effective, and safe, I think they're still really working on it. And I don't know if this would be labor intensive, you know, and at some of these commercial yards, I can't imagine that being something you could do very practically. But you know, there's some benefits, I guess, if you get it to work, if they could perfect this somewhat to eliminate some of the drugs and chemicals. And yeah, I put a link here for you guys to read into it. I don't know what I think about it, other than I haven't used it at this point and have no plans to do so. All right, so other things that we have to think about when we're thinking about Varroa is something called comorbidities. So Varroa often comes with friends, diseases, right? So there's oftentimes, if you have Varroa, which y'all do, there's other things you have to consider. And one is the viruses that come along with Varroa. Varroa is considered to be a vector of a wide variety of other infections, primarily viral infection. Every time I turn around, they are identifying a new virus for honeybees. So there's at least 20. Yeah, I'm tired of changing the number on the PowerPoints for these things, but many of them have very similar clinical signs in bees. So we can try to diagnose them, or at least say that they have a viral disease with some of the clinical signs. And you will see bees that have deformed wings. This is an extreme example on this side. And the wings will shrivel up. You will see hair loss. You will see neurologic signs in these bees. Some of them will be seizuring and just dying. Large number of bees dying that are infected by these viruses. Now, how these viruses get in is they're vectored by the Varroa mite, but you also have to understand that when the Varroa mite attaches itself to the bee, it makes breaks in the exoskeleton of the bee. In our last talk, and that's a big part of innate immunity. So imagine it's having large open sores in your skin, and that's kind of what the Varroa mites do to the bees. So it again allows additional access for these viruses to get into the bees. Ultimately, to confirm, you know, what type of virus is infecting our bees, we have to confirm it via something called PCR, which is a test polymerase chain reaction. It's a test that a lot of laboratories can do, but it can be hard to find a lab that can run all of these tests. But we do have some, you know, bee labs like in Beltsville, Maryland. But this gets, it's hard to do, and it gets expensive to do, and it's more of really at a research level that we're doing this, not so much of a clinical field. But some studies are going on to test for this. We can identify it. But if you have viral disease, it really doesn't matter which one. It's just that you've got it. But certainly from an academic perspective, we're trying to figure out a little more on that. There is no real treatment for these viruses. If you've got it, there's nothing that we can really do specifically to address the viruses at this point, other than trying to control for Varroa. Again, this would be a great If the vaccines can start to work, this would be a great target for those vaccines. And it may be one of the few things that could maybe reduce viruses in honeybees. So I hope it works. So again, there's 20 or more of these common bee viruses. Some of the more common ones I have listed. This certainly is an exhaustive list, but you can see acute bee paralysis, and you will exhibit problems moving or abnormal motility and seizuring-like behavior. Deformed wing is named that way because their wings do get shriveled up, or they're moved in odd configurations. They keep naming these, by the way. Deformed wing virus, that we used to think it was just one. Now there's multiple ones, by the way. And there's deformed wing virus A and deformed wing virus B, which used to be a Varroa virus. I can't remember what the D stands for at this point, but it's formally known as. But they're getting new names as they're identifying them a bit more. One of the things that my students are starting to work on right now in our own lab is we're going to be testing our bees, and then potentially bees in our community for deformed wing virus, and be offering tests to local beekeepers is our goal, as kind of a community service for our beekeepers in the area. But we're working on the protocol to actually test, and we're trying it out on our bees first. So we're doing a little bit of our own PCR at our little college there. And then there's all different types of other viruses, some of them named from a geographical location, but many of them cause these very similar paralysis, neurologic signs, deformed wings, loss of hair, and really just death. Lots of dead. So in addition to the viruses, there is a name, of course it's PMS, parasitic mite syndrome, where the hive really starts to collapse. It's a systemic disease now throughout the entire colony. The adults are infected, the larvae, the brood are all infected, and you have Varroa running rampant, you have viruses running rampant, usually multiple viruses at this point in time. And you really start to get this spotty brood pattern, low population. It can look like a lot of other brood diseases, really. The colony may become more aggressive than it had been. It's like the sick dog in the corner, right? I mean, it's a sick animal, they tend to get more aggressive. And this often leads to collapse. And once you get to this point in time, this hive may be beyond repair. Probably not going to make it through the winter. And you may start to wonder if you have some other brood disease, like one of the foul broods, but can look a little bit like that, but not exactly. So one thing we have to think about, again, depending on what's going on in your neck of the woods, and this is a year, 2 years over time, where you have different seasons. You guys are a little colder than I am, but this is from Randy Oliver. You guys have probably heard of Randy. Where through the seasons, there's different things that are going on with your hive as far as them bringing in pollen, them bringing in nectar, right? Which typically peaks spring through fall and peaks in summertime. And this black line here is your bee population, okay, that peaks typically in the summertime and then goes down to the winter. And that's cool in the summer. It's one big party here in May through August, right? Everything's good. You got lots of food, you've got lots of bees. But unfortunately, when our diseases come in, Varroa, and this is deformed wing virus, this is kind of representing all the viruses, are going to start actually peaking as our nutrition is going down, as our bee population is going down. Nosema tends to take place here. I don't know if you guys have issues with Nosema out there. It's a little drier out there. Maybe you don't have as much problems with it as we do in the east. Maybe you do, maybe you don't. You guys can let me know. And then in the springtime, we tend to get things like European foul brood and chalk brood and things coming in. So the point of this is a lot of our diseases tend to hit our hives whenever they're down, whenever they're low on population, whenever they're low on nutrition. And then you also have the environmental stress of the winter going on. So as beekeepers, we have to do what we can to intervene to reduce these so that they can endure the diseases that hit them in the off season. So it can be very difficult to determine, winter doesn't kill your bees, but it sure does help the diseases come in and have their effects. All right. So now we're going to talk a little bit about emerging diseases. Emerging diseases are things that are coming on the scene. Maybe we don't have them here yet, but maybe they're on the way. Some of these are very much related to Varroa. So Varroa is in Australia. I talked to you about this at the beginning of the talk. They first detected it in June 2022. Australia has been Varroa free since then, and they've done a really good job with their biosecurity of keeping Varroa out. As being a big island, they had the ability to do that. And while the rest of the world suffered with Varroa, they were Varroa free. However, they got it now, and it's on their mainland. And this should be, sorry, there should be an L there. Currently, it's not locking down, it's locking down. And I don't know if you guys have read much about this, but Australia and their government is freaking out about this. And I read a bee culture article about this too, and I thought I might get in trouble. So far, the Australian government hasn't showed up in my delivery. Maybe they will. And the thing is that once it makes the mainland, and this is, I don't care if you're talking about Varroa or whatever disease, once you got it, it's there, man, it's yours. And now it's no longer, you can't eradicate something that's already showed up at your door. It's going to be there, right? Now they have to kind of switch to, this is my opinion, but they got to switch to managing this disease, but they're still trying to eradicate it out of Australia. And they are locking down hives. And they're putting up red zones, and they're burning all the hives. They will put up a radius, a 5-mile radius, and every beekeeper has to burn the hives, whether they have Varroa or not. They're also trying to bait the feral hives in. So they're baiting feral hives and killing those in the red zone. And they started doing this. I realize Australia is on the southern hemisphere. So they have very much like the United States does, with migrating beekeepers and commercial beekeepers moving their bees around in the springtime. They started doing a lot of this euthanization and this lockdown really towards the fall. And you could be like, well, that's the fall for us. I'm like, no, that was the spring for them, because they have opposite seasons. So they started implementing all of these eradication measures right whenever their industries were supposed to be moving their bees around for pollination. So again, this is my opinion. I think they're making a big mistake over there. I think they've got to join the rest of the world and realize they have Varroa and start managing for it like the rest of us. But they are still trying to eliminate it. Last I heard, it's still spreading around, and it will probably take several years. If you want to do a study of this, you can look at what happened in New Zealand a couple of years back. New Zealand also became a Varroa state, I guess. They didn't have Varroa for a while, but they do now. And they have it now, and they've just had to come to terms with the fact they haven't. And Australia hasn't done that yet, but they're, my money would be on Varroa. It's there, and they're probably going to have to learn to deal with it. Unfortunately, they are burning. I don't even know. I think it's in the millions now with dollars and amount of hives that they're destroying. They also, by the way, found Varroa fly. You guys heard of Varroa? And they didn't think they had this there either. And it's interesting. They started looking for Varroa, and they discovered they also have another parasite they didn't have or didn't think they had, but they do. Varroa fly is a parasite. It's not nearly as devastating as Varroa, but it does tend to hang out on queens. So the queen trade can be one way that you pass that around. Hard to know you have something if you don't look, but they're literally teaching their beekeepers for the first time how to do mite count. All right, so speaking about more emerging diseases, there's also another mite called Tropolaelaps. And there's two species. One is Clarae and Marcediae. And this mite right here, this big fat one, that's our friend Varroa, and this one is Tropolaelaps. So they tell me you can still see this with the naked eye, but you know, it's about the third of the size of a Varroa, and I can barely see a Varroa. So you better put on your glasses if you're looking for this guy. Tropolaelaps right now is not in the United States, but we believe that it's probably inevitable it's going to show up here. It is considered to be a potential emerging parasitic disease, and it does originate, its original host is from Asia and giant honeybees. The USDA is actually paying attention to this, and this is the only reportable disease in the United States, if any, for honeybees. If you see this or suspect that you see Tropolaelaps, you are supposed to call USDA immediately and report it. One is significant. Okay, so we're not doing a mite count where we have, you know, 10 or 20 or whatever in a mite count. Any one of these is going to be considered catastrophic. It's probably going to come in through the South, I would imagine, or maybe through Canada potentially. But we should be on the lookout for this one. I wish I had good news to tell you about this one, but I don't. Harder to see than Varroa. It does have a very similar life cycle and what it does to a hive. It's also potentially killed by all of the Varroa treatments that we use. So if you need another reason to treat for Varroa, if you're treating your hives for Varroa, you're also potentially treating them for Tropolaelaps if it would ever come into play. But the life cycle is faster than Varroa. So you're going to see hive collapses occur, not just in a year or a couple years. You're going to see hive collapses in a couple months, maybe even a couple weeks with this parasite. The one good thing about this parasite is that they do not parasitize adults. They can only parasitize the brood. So they have a very short phoretic phase, which is a little bit of a weakness for them because we can take advantage of that somewhat whenever we have broodless periods. All right. So Be Informed has some information on them too. So I have some more information here for you guys. You can check out these sites. USDA is actually starting to recognize bees a good bit. They're very well represented, more than they used to be as well. Honeybee Health Coalition, Be Informed. If you want to read anything good, anything with Dr. Sammy, he does a lot of Varroa research. Anything he puts out is certainly worth a good read on Varroa. All right, so again, if you have any questions for me, you can always send me an email. You can check out what we're doing on GCCB projects. Again, I write for Bee Culture. You usually know what I'm thinking when I'm writing those articles too. So any questions that you guys have for me?
Hi, thanks so much for that. It's really informative. And I'm a newbie, so apologies if this is a very basic question, but I wonder if you could talk a little bit about any abilities that bees have, in terms of their own resistance to Varroa?
Mhm.
I have a couple follow-up questions.
Yeah. So our own bees developing resistance on Varroa. Yeah, and I think that's it's a little bit of a controversial subject, and there's different camps on this. So I will try to give you all of the perspectives and not step on too many toes. You probably have heard of different beekeepers trying to breed, bees, and we're talking about Aphis mellifera, okay, which is the bees that we have here. They're trying to breed or have lines of hygienic bees that are mite biting bees or leg chewers or whatever they want to call them. And there are people that are on that in that camp, and there are people that are out of that camp. What I will say to you is that it's very difficult if you understand how bees breed. When you have a queen and she goes out, especially if you are breeding your own queens or rearing your own queens, if she goes out and she's going to mate with X number of drones, anywhere from half dozen to maybe 20 drones. So it doesn't take long to dilute the genetics. So even if you have a queen that's perhaps resistant on her line, once she's mated or once she swarms, and I've seen a lot of these designer queens, you get them and they go up into the trees, and then they're gone. It just doesn't take long for once multiple throughout the season you get multiple swarms or new queens coming in. That can be really difficult to do unless you're really in a remote area where you can control kind of the 3-mile radius of what bees are there genetically. And that can be really difficult to do, especially in my area. Maybe that's easier out in Utah, where maybe people are spread out a bit more. The other thing that I'll tell you is from a completely evolutionary standpoint. We got Varroa mites from Aphis cerene, which is the Asian honeybee, and that's where Varroa kind of grew up and was evolved with. And those honeybees and those mites, were evolved together, and there's some resistance in Aphis don't get as ill as Aphis, but that type of relationship, that type of more of a tolerance of a parasitic relationship takes a really long time to evolve. It's not something that you can do in a couple seasons. So while I think certainly you can have some more hygienic bees that may be helpful, but trying to create resistance in a species that breeds the way bees do over a short period of time is probably not realistic.
Thank you. I was wondering, even just on a simpler level, about are healthier bees less susceptible, or does it even make a difference?
Yeah, and that's the crazy thing. Like, you can have a beautiful, booming, Italian beehive, right? And it can look fantastic, in July. And the problem with that is that big booming hive has lots of brood in it, and maybe lots of drones brood. And that creates an opportunity for those mites. And the more brood you have, the more drone brood you have, more mites you're going to have, and you get an exponential growth explosion, and the mite curve goes up and the bee curve goes down, and that's when we end up with collapse. And it can happen. I think everybody, if I can give you all homework, and this is going to take a while, and I realize Utah, when is your fall month? Is it October?
Yeah.
October would be considered fall. It's not snowing yet, right? Or not that much. You can still maybe get into a hive. Yeah, depending where you live. I never realized that you guys got the mountains and you got the plains, but you need to take a fall, whatever that is, which around here will be October. Maybe October for you. For the mountain folks, maybe it's, I don't know, July. But you need to take a fall mite count. You need to take a fall mite count and see whenever you got 30 mites or more mites you have a hard time counting. You got that many in that count. Everybody needs to have that freak out moment and then realize they got to start developing a treatment plan. Yeah.
Thank you. Just one quick follow-up and then happy to pass the mic.
Sure. Sure.
I was just wondering if bee forage makes a difference, like thinking about a time-based treatment. If bees are eating a lot of thyme or other herbs that have antimicrobial properties, would that give them some resistance?
Yeah, I mean, certainly, and there's all different types of camps on, what kind of, do we use synthetic products? I only want to use organic products. I want to use no products. I think it's unrealistic to use no products. I will take that stand. Organic products, I don't have any trouble with organic things. That's, thymol and formic and oxalic acid. Those are all organic products, but you pull out the product directions and the package insert on that. They're chemicals. They're chemicals like anything else, right? And can harm the bees and they can harm you if you use them incorrectly, just like any synthetic can. So I think, thymol is a very natural, it's an essential oil, but if you use it incorrectly, it can kill your bees. It certainly can kill your queens, and it can topically harm you too. So, organic products certainly can be very effective. But they're chemicals like anything else, and you're going to get the scientists on this. Synthetics, they're hard to stay away from. You don't have to use Apivar, Traz, but whatever you use, make sure you have multiple things that you're going to use at the correct time. So you have things maybe you can use whenever you have honey on, things that you can use whenever you have brood and when you don't. But as far as, putting lavender in your hive or something like that, I mean, I don't know, it might make it smell better, but it's probably not going to take care of the mites.
Thank you.
So I just want to ask you something. I love that you talked about study the biology, because if man had bothered to study from the master who created this planet and the entire life support system, we would realize that it is more intelligent than anything we could design. And the plants are there for a purpose. And so I teach permaculture design. In my foraging forest, I have 37 kinds of berries. I have 105 fruit and nut trees right here in Utah. I live on the bench.
Yeah.
I have hundreds of herbs, especially the mints. And the anise hyssop, which is native to Utah in the mountains, has a special immune boosting that has been found to really boost the immune system of the bees. And so I prefer to go more like we talked about, foraging, build the immunity. Because what happens in our food forest as we watch nature do what it does best and step back and watch and learn from, instead of trying to impose what we think it should be doing, what we learn is that nature itself has the ability to use what's around it. So you plant a whole bunch of elderberries, you've got antiviral pollen. You plant a whole bunch of anise hyssop, mint, and you got another immune boosting against parasites. And so there are many natural things that if we took more time to study nature and experiment it, we need to do experiments, do control studies with all your little treatments, and then put them in an environment where they're getting these natural viral protected, immune boosting plants, and test and see what happens over time. Are these hives going to naturally, which is what I'm going to vote, I'm going to always go on the side of nature, not what man creates. And so I wish we would do more. What do you think, Doc?
Yeah, so if you go back to my slide, one of the top things, actually the top two things that you covered there are understanding biology, right? And then good nutrition. So, you know, we know that bees that have diverse forage, better nutrition are much more equipped to deal with anything, you know, whether or any other disease. So, you know, I'm definitely on board with that. Some of the problems that come along, though, you know, is that we live in a fallen world, and things aren't always perfect. Now, maybe you've got it sounds like you got a nice piece of heaven out there from what you're describing with all of those plants and things. You know, and if you can keep your bees in a nice little area that's undisturbed and very natural, you might be able to escape a lot of these diseases. The problem is that, you know, realize I'm living in Pennsylvania where maybe the population's a little bit closer together. You know, I can't draw a line where I can't find beekeepers within 3 miles of me. Okay. And I actually live kind of out in the country compared to most folks. But, you know, you've got people that are urban beekeepers that, you know, you have concentrations of people and hives and there's no natural forage, and you know, what do you do with that? It created a lot of unnatural situations in our stewardship, and we have to find solutions for dealing with different situations based on those different ecosystems that we've created. So, you know, that may not be something any of us likes, but it's sort of the reality that many of us have to live in. So hopefully that helps to answer your question. And as far as, you know, doing studies, you know, I don't care if it's a synthetic product, if it's a natural product, organic, whatever you want to call it. You know, plants, most of our medications have come from plants or have been synthesized from plants and things of that nature. And yeah, as a scientist, I'm like, hey, take it and study it. Problem is, you've got to get big business to come in and take it and study it. Good luck. That's the hard thing. And then we can get into politics pretty fast.
Are there any other questions for Dr. Farone today? No.
Did that answer your question, ma'am? I don't know if she's still.
Yes, thank you, Doc.
You're welcome.
Dr. Farone, this is a little bit off of your presentation, but I think we've been talking about your conference mentioned. I kind of did a little research on you, is good on Google, but talking about that as a veterinarian, there's a gap between veterinarians and beekeepers. So it kind of sounds like you kind of have kind of a push for you know, wanting to try to build relationships back between those two, and the veterinarians have kind of an obligation to help the beekeepers. And
Yeah.
we've had some problems here trying to be able to, you know, as we find foul brood in our hives and having that being diagnosed by the inspectors that is foul brood and it being treated, but not having the resources available from for being able to have a veterinarian come out and inspect the hives. And by the time that they do, it's, you know, it's just a long process and the hives taking a toll. And anyways, and so I was just curious to see what things you're doing or what you suggest we can do to kind of help the veterinarians.
Yeah.
Kind of
No, it's
yeah.
I get your question. I get that a lot, and I'll do my best to answer that. You know, this problem came up in 2017, and I don't think anybody was really prepared for it. I mean, our government and their infinite wisdom had sort of a good idea, you know, to try to combat antibiotic resistance, but they just kind of threw the rule out and said go. And you know, neither industry was ready for it or had a plan. And things like this, you know, take years to try to figure out. And this was a bit of a ringer in everybody's world. Yeah, so I hear from the beekeepers, and I'm very empathetic, and there just aren't, at this present time, a lot of veterinarians that are knowledgeable in bees and or willing to see bees and or trying to figure out how they can see bees in their within their practice, their business practice. So you're right, it's a problem. What I would say to you though is that antibiotic use isn't the best thing to do. We really do need to find a solution for that. That's why I'm hopeful that the vaccine actually works. Again, I don't know. It's either going to be one of the greatest things or a complete fiasco. I don't know. It does work and can give us a better solution than the antibiotics for foul brood, both American foul brood and for European foul brood, by the way. But what am I doing? Well, I'm one person, so I'm trying here. But I realize my job is, I'm a professor at Grove City College, which is a little Christian college in Western Pennsylvania. And when this happened, it was an interesting problem. I read about it, and when I first read about it, I thought, bees, this is crazy. What else do they want veterinarians to do? But the more I thought about it, the more I looked into it, and I saw that bees were animals, and they were agricultural animals, and they had so many different characteristics of pathology and biology that we see in other animals. It just really intrigued me for something to try to work on. So I took a sabbatical and I went to France, where they actually have a postdoctorate program for veterinarians in bee medicine in France, and in Europe. Honeybees are just part of the normal curriculum that all veterinarians get. They go through rotations for chickens and cows and pigs and bees. It was the normal thing to do. So I started learning from them a little bit. Got to be in France, which was cool. I got to hang out in Scotland a little bit too. But that's every veterinary school over there has an apiary. It's just part of the whole system. And then I came back and I shadowed a bunch of beekeepers in my area, Pennsylvania, Ohio, West Virginia. Went out to Montana and shadowed some commercial beekeepers, big operations. And just, you guys as a industry just kind of let me in and let me hang out with you and learn what you do. And became a beekeeper myself, obviously, in the process. And we have our own apiary. Here's some of my kit, actually the picture that's up here. Still got that up there. It's some of my students in our apiary at the college. And I met some people. I was asked to start writing for bee culture. I have tried to write some things for the industry. I wrote biosecurity recommendations for the industry for veterinarians. I do continue education for veterinarians. So I go to veterinary conferences and I speak to veterinarians on how to treat bees and what they should do, and teach them about biology and teach them about diseases. Like last year I did 12 different conferences, okay, and realize this isn't my full-time job, right? This isn't what I do in my part-time. And I also speak to beekeeping clubs, just like I'm speaking to you, and I speak to community groups and student groups. And I'm on a board called the Honeybee Veterinary Consortium. You guys can actually get on that website, and we try to be an organization of veterinarians that are concerned about bees and offer services for beekeepers. That membership has grown. It's not huge, but that membership has grown, and we are trying to develop maps that beekeepers can access so that they could find honeybee veterinarians, or at least veterinarians that are willing to come out and see bees if they want that service. So we're developing that. We're also developing a certification process. I'm actually on this committee for veterinarians that are already out in practice, and it will be an extra certification, like 150 hours training additional on honeybees, so that they can carry the certification, so that beekeepers can actually ask about that And you can at least know that the veterinarian that you call has some knowledge, some extra knowledge in honeybees. It's not the first time I've ever looked at a hive when they come out to your house. I'm also, and this is a unique thing for you guys. The AVMA, which is the American Veterinary Medical Association, has a bunch of different committees. And one of those committees is the Agricultural Animal Liaison Committee. I am now sitting on that committee as a representative representing honeybees. That is the first time there has been a seat on that committee representing honeybees. That's this year. What that committee does is they advise bills, essentially federal bills that are going and being considered in Congress for writing rules in agriculture and things. So that is a committee that I'm now sitting on, and I'm representing bees to the feds on a lot of these bills that come up, the agricultural bills. So that's kind of been a bit of a big deal. I also consult with people. Like right now, I have the same question sitting in my email box in a conversation with a beekeeper that I'm having with in Wisconsin, the same frustration, and I'm trying to help them out and give them some advice. But that's kind of what I try to do in my spare time. You know, I think it's going to take some time. Oh, I know what else I forgot. The vet schools. We are incorporating now. There are at least 6 vet schools that have bee courses in their curriculum, which has just been developed over the last couple of years. And there's at least 6 that have bee clubs. So we now have veterinary students, more veterinary students being trained in bee medicine too in the United States. So I know I'm kind of rambling on here, and that's a long answer to your question, but those are things that I'm trying to do, and there are, you know, a handful of other veterinarians that are trying to organize this too. But at this point, you know, most of us have our real jobs are in academia somewhere and or clinical practice as, you know, full time, and we're trying to help the industry, our industry, be able to serve your industry and bridge some of those gaps and talk to apiarists as well, state apiarists, and develop relationships with them. I had a conversation with a couple state apiarists. That's actually the current article that's in Bee Culture is talking with state apiarists too, because they're kind of the third, you know, arm of communication here with veterinarians, bees, and apiarists. Everybody trying to work together really with the same goal of, you know, promoting bee health the best that we can. Does that answer your question, sir?
Yes, thank you.
Anything else for Dr. Farone today? Dr. Farone, thank you so much for spending time with us. We really enjoyed it.
Yeah, you're welcome. I'm glad that we could at least do this online. I'm so sorry I couldn't be with you guys. I was really looking forward to coming out to you all and being able to speak to you all in person. Again, if you want to get in contact with me, I think you have my contact information. And Brian, I'm sure we'll be in touch at some point whenever you guys wrap things up.
Certainly. Thank you so much.
All right. Thank you, guys. Have a good rest of your conference and have a good evening.
Okay, we'll break now until 2:45, and we'll see if we've been able to work out the difficulties with my call for 2:45.
Thanks, Tracy.
Gonna give some more dog prizes out here real quick. Last of the day. Another hive and honeybee book. I'm gonna do on this drawing here for 021.
Nice. Hey, Mike.
Nice. 041, so we give a full B here. 039.
Mike, we're just taking a quick break. We'll be back at it in about 5 or 10 minutes.
Yeah, okay.
Thank you. I got a really cool, I don't know, I can't remember the gal that made these or brought these, somebody, one of the members donated this. There's some really interesting wood cutout, they're done with a laser cutter, tiny. Will these, and, I think this is a tablecloth and some,